What precisely lies at the edge of the undeniable universe? Without question, this has stayed a secret for a surprisingly long time, controlling interest and fueling debates among researchers and aficionados alike. The James Webb Space Telescope, JWST, holds the key to uncovering this vast mystery. With its powerful focal core, it looks further into space and has indeed offered significant insights into what lies at the edge of the visible universe. When we analyze the edge of the universe, understanding the concept of the observable universe is fundamental. The observable universe includes everything that can be seen, measured, and studied from Earth or our space-based telescopes and exploratory probes. Currently, it contains stars, galaxies, and other brilliant objects within our observational reach. So, what's the difference between the universe with a capital U and the observable universe? In simple terms, the observable universe is just a small part of the whole universe that we can study and understand. While the total size and shape of the entire universe remain unknown, the observable universe has an estimated width of around 93 billion light-years. A light-year is the distance light travels in 1 year, approximately 5.88 trillion miles or 9.46 trillion kilometers. Therefore, the width of the observable universe, 93 billion light-years, spans an incredibly vast area, roughly 546.8 trillion kilometers, illustrating the immense scale of our cosmos, which is hard to comprehend. Why is the universe so incredibly enormous? The answer lies in its early stages. The theory of how things came to be tells us that approximately 13.8 billion years ago, the universe was born in a massive explosion, known as the Big Bang. This event triggered a rapid sequence of events, and since then, the universe has been expanding at an accelerating pace, driven by mysterious forces like dark energy. As the universe expanded, particles of matter began assembling due to the force of gravity, forming remarkable structures like stars, galaxies, and eventually even planets like our beloved Earth. Over billions of years, these massive structures grew and became more complex, leading to the extraordinary diversity of objects and phenomena we observe throughout the universe today. Despite the vastness of the universe, it is predominantly empty. To put it in perspective, if we shrank our entire local group of galaxies to the size of a quarter, the nearest star would still be 2 soccer fields away. This is just within our Milky Way galaxy, one among billions in the observable universe. You might wonder why we can never see the entire universe. There are 2 factors that explain this. The first reason is that light takes time to travel through space. When we observe distant objects in the universe, we're actually seeing them as they were in the past. The farther away an object is, the longer its light has taken to reach us. Thus, by observing distant cosmic structures, we're essentially looking back in time, unraveling the history of our universe. The second reason is the universe's expansion. Imagine spots on the surface of an inflating balloon. As the balloon expands, the spots move away from each other. A similar principle applies to the universe, where structures are drifting apart as space itself expands. This expansion causes the light from distant objects to stretch, shifting toward longer wavelengths, which we perceive as redshift. Eventually, some objects will move beyond our observational reach as they retreat past a certain distance. Considering these factors, it's not surprising that we haven't seen the entire universe yet. The idea of the edge of the universe is a fascinating subject that has captivated experts, academics, and thinkers for ages. We have an extensive array of theories about what lies beyond, yet the truth remains elusive. However, 3 theories stand out. The first hypothesis suggests that the universe continues forever, based on the cosmological principle, which states that the universe is isotropic, meaning it appears the same in every direction. If this principle holds true, it implies that the universe extends infinitely without an end. The second hypothesis proposes that the universe is finite but doesn't have a clear edge. Instead, it suggests it's like a giant sphere, and if you travel far enough, you will eventually return to where you started. The third hypothesis is the multiverse theory, which suggests that our universe is just one of many. Imagine a multitude of parallel universes, each with its own set of rules and properties. These universes could be entirely different from one another or somehow interconnected. Having discussed theories regarding the edge of the universe, We now turn our focus to a remarkable device that holds the potential to reveal information about these mysteries. The James Webb Space Telescope, JWST. This advanced telescope allows us to look far back in time and discover unexpected objects from the early universe. The JWST, with its high-level capabilities, has enabled astronomers to peer into the beginning of the universe. Prepare to have your mind blown. They have inadvertently discovered something unexpected. In a new report published in the journal Nature, the JWST found 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Scientists were only expecting to find small, recently formed galaxies, but the JWST captured them. They are way larger and more surprising than anyone ever imagined, challenging what we thought we knew about the early universe. But that's not all. Researchers also found something incredible. These galaxies are as mature as our 13-billion-year-old Milky Way. The mass of stars within these objects amounts to several times more than that of our Sun. According to the analysis, one of them specifically may be as much as 100 billion times our Sun's mass. For comparison, the Milky Way contains a mass of stars equivalent to about 60 billion suns. This telescope has exceptional power. It can see things that are invisible to our eyes by utilizing infrared light. It captures the faint glow from old stars and massive structures that have been around seemingly forever. This means the JWST could literally take us back in time, providing a glimpse of what the universe looked like around 13.5 billion years ago. Now here's where it gets truly interesting. The universe is estimated to be around 13.7 billion years old, so this discovery has turned things upside down. It seems like it's rewriting the history books. These massive galaxies, nicknamed universe breakers, have left experts scratching their heads. They challenge most of the models we had for early galaxies. We used to think galaxies started as tiny clumps of stars and dust, gradually growing over time. But these universe breakers proved us wrong. When the Webb data and high-resolution photos from the telescope were released in July 2022, scientists were astonished. They were stunned when they saw these galaxies as massive sources of light, questioning their understanding of the data. The sudden appearance of these massive objects, which shouldn't have been found, shocked everyone. By using spectroscopic techniques to analyze light across different wavelengths, scientists can uncover crucial information about these galaxies, such as their structure, size, and distance from Earth. Interestingly, this monumental discovery wasn't even on the initial list of things scientists expected to find with the James Webb Telescope. It exceeded all expectations and developed much faster than anticipated. There's even a possibility that some of the objects found using Webb data might be something completely different. While most are likely galaxies, perhaps a few could be concealed supermassive black holes. Here's the captivating part. The known mass of stars in the universe is now believed to be significantly more than we previously thought. This revelation is still astonishing, even if we consider only half of the model in the new discoveries. The new findings focus on 4 galaxies with redshifts greater than 10. This means they are really far away. The Hubble Space Telescope recently spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. Additionally, the JWST's Advanced Deep Extragalactic Survey, JADES, is a major program that has been allocated more than a month of the telescope's time. Its goal is to provide a comprehensive study of the early universe. In 2015, a consortium of instrument teams proposed this project, forming an international collaboration known as JADES, comprising over 80 astronomers and experts from 10 different countries, starting with NCAM. The JADES program dedicated 10 days of mission time to observing a portion of the sky, including the Hubble Ultra Deep Field. For over 20 years, astronomers have been studying this region using various large telescopes. By focusing on the field in 9 different infrared wavelength bands, the JADES team made a remarkable discovery. Nearly 100,000 distant galaxies, each billions of light-years away. Then, using the NIRCam spectrograph, the researchers collected light from 250 faint galaxies during a 3-day observation period. This allowed them to reveal the properties of the gas and stars within these galaxies and obtain precise redshift values. With these measurements, astronomers can determine the intrinsic brightness of the galaxies and estimate how many stars they contain. This allows for a comprehensive study of galaxy formation over time, even without direct information on their initial growth stages. Studying galaxies can be as challenging as understanding people. The early stages of stars significantly influence the fate of galaxies, similar to how our early experiences shape our lives. This is an extraordinary time in history. The groundbreaking capabilities of the James Webb Space Telescope are answering many questions about cosmic structures. NASA's premier Space Observatory Telescope is reshaping our understanding of the universe and revealing a treasure trove of new discoveries. The James Webb Space Telescope, a pioneer in scientific research, is providing us with astonishing insights into galaxies, planets, stars, and other fascinating cosmic phenomena. Launched in December 2021 and expected to operate for over a decade, Webb is just beginning its incredible journey. Surpassing the benchmarks set by its predecessor, the Hubble Space Telescope, Webb has captured the imagination of scientists and the public alike, inspiring a surge of intellectual energy. People worldwide are eager to analyze the telescope's raw data, share photographs, and gain new perspectives. Following the successful deployment of the JWST, astronomers are finally getting a detailed look at the universe's early stages. Despite earlier doubts about discovering mature galaxies within 400 million years after the Big Bang, it's now happening. This discovery of massive, mature galaxies has turned the field of astronomy on its head. The search for answers about the universe's earliest moments is a thrilling and challenging endeavor. It pushes the boundaries of our understanding and shows how science can reshape our knowledge. The JWST's findings remind us that the universe is full of surprises. We are just beginning to uncover the vastness of our existence and the mysteries that lie within it. Whether it's through exploring new theories, observing distant galaxies, or seeking answers about our place in the cosmos, we are on a quest for knowledge that never truly ends. The journey continues, and every step we take brings us closer to comprehending the profound nature of the universe.